So hi everyone, today in this video I will tell you that how to create a linked list data structure uh, using a Python, right? So in Python we will see that how to create linked list. So first of all, let me tell you that what are the linked lists. So linked lists are linear data structure present in Python. Okay, so in any programming language we can use this linked list. So linked list is kind of a chained data structure. So one node is attached to the another node with the pointers. We use pointers. So in linked list we are having some pointers, like in single linked list we are having pointer as next and head. In double linked list we are having pointers as previous, next and head. And in cyclic also we are having next pointer. So these pointers are points, are basically points to the next node. Okay, the node belonging to the first node. So chain wise, chainly manner, link list. Okay, so one is connected to two, is connected to three, is connected to four. So this is singly linked list. Okay, this is a way to represent the singly link list, right? Then uh, doubly linked list, right? Linked list. So in case of doubly linked list, we can traverse both the sides. Okay, both the direction in the forward as well as in the backward direction also. So doubly linked list. So here we are having a pointers like dot previous, okay, add dot next. And in cyclic, okay, linked list, in cyclic linked list we are having pointers as same, pointers like next only, and head, right? Head. In this also we are having head pointer that represent the first node of an element, right? Here also we are having head and next pointer. Okay, so the only difference is between the way we represent the linked list. Okay, so doubly linked list we can traverse forward as well as backward. In singly linked list we can only travel in the forward direction, and cyclic linked list we can travel in the cyclic manner. Okay, so the linked list are chain data structure present inside the Python, right? So after doing all of this, what we will do, we will first see singly linked list. Okay, so for that first we will create a class as node. Then we will create initial it method. Here we will declare data is equal to data. And what we will do, we will give data as an argument inside this initial it function as well. Okay, so this will initialize the variable. Then the next will be the next pointer. Okay, so this will simply create a new node. Okay, this will easily create a new node. So whatever data will be there, that will be assigned to the class itself, and we will take the next as none. So next will be the none, because each every new node will have no next element. We will assign that, we will declare and tell the data structure that this is the new node and this will be the next to the previous node. Okay, so now we will create linked list initialite. Okay, so here we will not take any type of data, right? Here we will say head node. Okay, so head will tell that this is the first node of the linked list class. This is the first node of the linked list card. So initially it will be none. Okay, now we will see that if the class is empty. Okay, so for that what we will do, self dot head is none, right? Okay, so this is empty. Okay, so this will check that is this linked list having some head element or not. If it does not have any self dot head element, it will simply show us that the class is empty. Okay, so this is the method. Now finally what we will do, we will insert a new node inside. So for that we will use this method. Okay, so here what we will do, new node is equal to node, and here we will create. So using this node class, we will create a new node. And now we will again check is empty, right? Is empty. So if the class is empty na, so we will assign self.head as new node, right? Otherwise, if the class having some self.head element, some type of element, then what we will say to it, that new node next is equal to self.head. Okay, new node next. So whatever the new node is will be, that next node will be pointing towards the self.head node. So okay, then self.head element, then we will update this to the new node. Okay, so this basically will assign the new node next as self.head, and then after, okay, after, so this is basically an way to capture the node before changing it, right? Before changing it. So this is a backup actually. Okay, backup, this is a backup. And finally, this is what we will finally changing the backup node to new node. Okay, right? So after doing this, what we will do, we will display the elements one by one. So for that we will create a, okay, while current print current dot data. Okay, current is equal to current is equal to current dot next, right? So this will what this basically do, we will assign current is equal to cell dot head. Okay, and the while loop will traverse one by one to the each node, okay, inside this linked list, and it will print the element one by one here, and then it will increment the current element to the next element. Okay, so it will increment, this is the increment basically. Okay, as we are only having next pointer, so we will increment the current element to the new node. Okay, now what we will do, here we will create a constructor. Okay, then for I in range of 110, then L dot insert. Okay, yeah, we will insert one by one display, right? Now we will display nodes. So you can see this is a way to represent the singly linked list. Okay, so this is a way to represent a singly linked list. Okay, now if you want to check the size of the linked list, okay, for checking the size of the linked list, we can same do current is equal to self dot head, and then size is equal to 0, while current, okay, what we will do, size plus 1, and then current is equal to current dot next. And here we will print the size of the singly linked list is size, right? Print simply new node. Now we will see that what is the size of the linked list, right? So you can see the size of the linked list is this, right? This is the size of the linked list. Okay, now say if you want to hmm, now if you want to remove, now if you want to delete a node, what we will do, value, okay, then here what we will do, if self dot head and self dot head dot data is equal to value, then what we will do, we will say self dot head is equal to self dot, okay, self dot head dot next, right? Then return. So basically if the element is at the beginning, okay, so it will first skip the self head to the next node and then it will return, right? But it will not change anything, okay, it will just switch over it. Here what we will do, current is equal to self dot head, okay, so current will be self dot head, then we will loop the current and current dot next, right? Current dot next, okay. So while loop will, what it will do, it will traverse to the current as well as to the next node, okay, and finally if current dot next dot data is equal to value, then what we will do, current is equal to current dot next is equal to current dot next, okay. So the next element, what we will do, so this will basically unlink the node, okay, this will unlink the node, right? So it will basically, what it will do, it will get the next node and it will convert it to the next double node, okay. So the first node will be traversed to the third node, this type, and then it will return. Now let's try to delete a node here, okay. Now try to delete the node. After deleting the node, what we will do, we will call to the display method, okay, we will call to the display method. Okay, so you can see here that it basically deleted the node number 5, okay, so fifth node is deleted. So this way it will work, right? So this way it will work. So this is the way the singly linked list we can get the idea about it, right? So thank you for watching this video. Hope guys this will helpful for you.